What's up, Molten Gamers? Today we are actually looking at something, as you saw in the title, a decoder. Now, most of you, if you're actually watching this, are like, why do I want to know about a decoder? Well, a decoder basically turns binary into decimal form. So we'll start off with this 1-bit decoder. First off, I'll show when it's in the off position, uh, obviously it says 0, and then when I flip this to on, it says 1. Now, obviously, I could have just done this with some basic redstone, but here we have this mechanism. Basically, what it's doing is it's inverting the signal of this, so I'll go ahead and turn this off. Oh gosh, the rubber banding is real. Okay, so basically what it does is this is inverted. So there's a redstone torch, and then another one here, and then there's some redstone going here to this redstone torch. Now, I'm going to show what it is here so you can get a good look at it. And basically what that does is if there is no signal going to this at all, so no levers are flipped, then this will not be powered, and therefore this redstone torch will be powered. And then we have this, which is double inverted, which is essentially just carrying the signal. Now, we have this redstone torch here. However, instead of having just one here, we have one that's here and one that's here. It's called a double inversion. It's pretty much the same thing as just carrying up the signal. So this is powered, which causes this to not be powered. So it says 1 is off. Now when we flip this again, 1 is on. This redstone, since this redstone torch becomes unpowered, this one becomes powered, and then this redstone becomes powered, which depowers this redstone torch, which is on the outside. Basically, just a ton of inversions is how this works. And then on this one becomes off because this power goes into it, which makes this one turn on, which makes this one turn off, which makes this one turn off, which makes this one turn on. So, right there, that's just a showcase of the concept, how it works, and I'm not sure if you actually understood that, but I think I did my best to explain it. And over here, we're starting to get into semi-useful, not really that much, a 2-bit decoder, which can display up to 4 different outputs, 0, 1, 2, and 3. So when nothing is powered, obviously the 0. When I flip 1, okay. When I flip 1, the 1 torch is on. When I flip 2, the 2 torch is on. And when I flip them both, the 3 torch is on. And the reason the 3 torch is on, when I have them both flipped, is because when you add 2 and 1, you get 3. It's simple addition there. How binary works is it goes 1, 2, 4, 6, 8, and up as high as you want to go, depending on how many bits it stores. This one stores, up to 2, so this is a 2-bit. Or we've got over here is a 4-bit. You could have a 3-bit, however many you want. Current computers today, they use like up to 64 bits, which can store very large characters. It can store the entire alphabet in capitals. It can store all the numbers, tons of different fonts, stuff like that. It's pretty crazy. Most people who are making like a demo computer, like for a project or something, they'll make an 8-bit because that's able to store up to 255 characters, which is usually enough to store a bunch of extras plus the alphabet and everything. So, to look at the redstone in here, this beginning one, like the last one, well, now we have 2 of these lines, and how the line works is the repeater goes all the way through to power these redstone torches whenever you flip the lever. This one, the normal inversion, which goes up here and then inverts to that or whatever. And then over here, this one right here, this one right here is an, what? Okay. This one right here, this line here, is normally inverted, so that whenever you flip the lever, this thing here will turn off or the torch here will turn off no matter what. So if you flip this lever right here on the left, this will always be off. Because this redstone torch will be powered, which will power this, which will turn that redstone torch off. And then we have our double inversion, which is what is currently powering it, and whenever you flip just this lever, then this will reinvert itself or whatever, so that this area is unpowered, and I'll show you that right now. see that's no longer powered, which means this one is powered. And it goes so on. Over here, we have just this one inverted, and then this one on the right, or this one on the right is inverted, and this one's double inverted. And then for the final one, both of them are double inverted. And going on to our 4-bit decoder, this one's actually somewhat useful. Those other ones, they don't really do much other than show how it works. I'm going to flip that lever off, it's bothering me. They don't really do much other than show how the concept works. Once you get above 4-bit, it actually starts becoming useful. And this one, as you can see, is much larger. And we have 1, 2, 4, and 8. So let's say 7. And how do we add 7? 4 plus 2 is 6. And we need one more, so 1 is 7. Now if we go over here, what do you know? 7 is powered. So it's pretty cool right there. It's called binary to decimal. This is, like 4-bit and up is where it starts to get cool. And of course, we have all of these are inverted, and then we have our 1 double inverted, and then we have 1 double inverted, and then both of these are double inverted, and so on with all the different combinations that create those numbers. At first it seems really complicated, but once you actually figure out how it works, like you test with it yourself, it becomes pretty simple. This one right here can store up to 16 different combinations. It can store up to the number 15, however, since there is a 0, it allows for 16. Let's pick another number, 13. 8. We need 4 for 12, and then 1 gives us 13. And boom, right over here, 13 is powered. So, you can do whatever you want with this. The point of this in actual computers is that it allows you to take the zeros and ones, which, like, right here, there wouldn't, in an actual computer, there wouldn't be these signs here. There would just, for example, be all these levers, or in a real computer, electrons on a magnetic tape. That's how small it is. And rather than a lever that's flipped on or off, it's a little electron, or on a single atom or whatever, the electron, whether it's on or off. I don't know exactly how that works, but that's kind of how it works. And it'll have those in an order, and you need to tell the computer what do those ones and zeros mean, which is what this is for. It converts all those ones and zeros into actual numbers. Or, like right here, this redstone torch, if I wanted to, I could wire it up with a certain output, and that certain wiring or whatever would make the output say, for example, the number 0 on that output. And then you could wire all these other ones up to that same output in the certain combination that you want it to be. So this alone, pretty much, you can... What some people say on Minecraft, they'll say they have a computer. It's really just a decoder, like a word processor. Whenever you flip something, it'll change it into binary, and then it'll change it into decimal or whatever, and then that'll go to the output. It's not an actual computer, it's just a decoder. Which decoders are pretty cool, though. I mean, they can do so much. And then finally, we have this one. As you can see, it's unfinished, but this one that is going to be able to store up to 250. So considering each combination, let me fly. Each combination takes up 2 blocks here, so this one, and then this one, and this one, and so on. 2 times 255, that's 610 blocks that way that this is going to take. I mean, just over here, I mean, you can see it takes up a lot of space. And over there, you can see it ends over there. That's only up to 64 because I did my calculations wrong. I was thinking 8 times 8. That's wrong. It can store a whole lot more than 64 numbers. So we got this pretty crazy thing. We'll kind of show how it works here. It can store up to 6. That's how it can store. These ones, they don't actually have anything hooked up to it at all. It's just the torch. So we're going to go back over here. We will say we can only store up to 6. So 4 and 2 is obviously 6. I did not know that levers output light. I did not know that. And you can see the 6 is powered. And we'll just do 3 as well. So 2 and 1. And we have 3 powered. So pretty cool. I'm going to go over here. I'm going to use another color of wool. What color should I use? Wool. I will use brown wool. and I'm gonna show you guys how you can make one. I'm gonna do a 2-bit one. So basically, you're gonna start off. You're gonna put these few blocks here, and you're gonna throw down 2 levers next to each other, and you're gonna do something like this. Place it back a few blocks, and then you're gonna build up a block so you can throw down your signs so that you know what is what. So we'll throw down 1 here and 2 here. I do not know why it goes right to left. I mean, technically, if you wanted, you could have it so it goes left to right from the least to increasing or whatever. It's just for people I've seen, for some reason, they've done it right to left from smallest to greatest. So I've decided that's probably some practice that you're supposed to do. So I've been doing it. And it doesn't really affect the output at all. It's just how it is, I guess. And then after you throw down that and the signs, you're going to throw down a repeater here, 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 and here. And we can do this. And for this tutorial, I'm not actually going to build up the walls very much. I'm just going to do it as much as I have to. Only as much as I have to. So over here, I have to build this wall up, I believe 3 blocks higher. I'm not exactly sure how high that has to go, but it has to go kind of high. 1-bit and 2-bit you can technically do with just a little bit of wiring, but once you get, I think just 1-bit actually, but once you get above like 2-bit in that area, you're gonna need to do this like inverting and stuff like that to make it easier. There are also ways you can do it with pistons. Personally, I don't like that very much because of the noises it makes and the time it takes for the piston to work. Repeaters are faster and more reliable. You're gonna throw down all your wool, and just to test, you're gonna, flip your levers. What? I got my things backwards. Okay. So you see, make sure that you're working, I guess. Throw down your torches. I forgot 2 of my wools. That would have been kind of a fail. And these first 2 torches, let's make the output first. How high does this go? We need to go another block, and then another redstone torch, and then another block. Okay, so this needs to be 1 block higher. Right here is where our output is going to be. Right? Okay. And then we'll do 0, and then 1, and then 2, and 3. And boom, boom, boom. So these ones right here, these are both just going to be normally inverted. That way if you... Poopy. Okay. If you flip either one of them, then one of these torches will become powered, which will power this, which will depower this, so this will be off. So if you flip any levers at all, it'll no longer say 0, which is what it's what it's supposed to do, because if you have a lever flipped, then the value can't be 0, because all the binaries are above 0. Just some basic logic there. So if we flip any lever, we flip this, it's off. If we flip this, it's off, and if we flip both, it's also off. So, these stupid skeletons. And then on this one, we're going to have the 1 double inverted. This one is going to be normally inverted. Now, technically, double inversion is literally just carrying the signal up, but I'm calling it that because it's useful, I guess. I don't know. I just like to call it that because it's cool. We're going to throw down... to double invert, you have to make sure you're doing this how I show it. You have to throw 1 torch down here. The first one has to be here. The second has to be here. And then the third, make sure these 2 are sitting on the block. And then this one, these should be on the side of the block. And then this one should be on top of the block. If you do this wrong, then the double inversion won't work quite right. So make sure you have that right. And then do this. And there, now it's automatically off. But if you flip the one lever, it'll be on. Magic. Yay, cool things and stuffs. And then for this one, you're going to do the same thing, except you're going to double invert the right one instead of the left one. I'll just do that real quick. Invert you. Double invert you. Or 1 sec. Okay, I'm back. Okay, now we're gonna throw down this signal. Okay, and now that we have this right one double inverted, if we flip this lever over here, then this will be on. If we have both of them flipped, it'll be off. And so on. If we just have this one flipped, then it'll be off, There's all those different combinations. Now we're gonna do the final one. And this one, we will double invert both of them. So basically, you have to have both levers flipped or it will not work. This is sometimes called an AND gate. Because you need both flipped, cool stuffs. I think that's called an AND gate. I mean, just watch me be entirely wrong about that, but basic logic gate used in all wirings and stuffs. Very important. So now this will always be powered, and the only way to have it unpowered is if you flip both of these. So that's cool. So right now, we finish this off. This is what our little 2-bit binary to decimal decoder looks like. So we flip or first we have our 0 torch on because we don't have anything flipped. Currently the value is 0. When we flip 1, now the value is 1. When we turn that off and flip 2, the value is 2. And now if we flip them both, they're adding 2 plus 1. We get 3. So that's pretty awesome. Basically what this is doing is technically it isn't converting it to a number. This number is just as how you visualize it. It's just turning it into a single output, and that single output can be whatever you want it to be. So that's my video. I really hope that actually made sense, but there was this tutorial on decoders. Decoders, as you could probably tell, are a very important part of a computer. It's what turns the zeros and ones into single outputs for the displays and such, and for the ALU, which does math. I'm probably going to do a series on this, or not on this. I'm not going to actually make this a series like in the title-wise, but I'm going to continue doing this, like making different parts of a computer in Minecraft. And after I've made all the different fundamental parts, I'm probably going to put them all together and make one of those really cool redstone computers that you occasionally see. So, that's it for today. If you enjoyed the video, leave a like and subscribe, and have a nice day.